welcome to once again to those classes and this classes they are devoted to explain some of the basic concept of the physics for class 12 cbsc board, and we are following the ncrt book. Now in this video I am going to discuss some of the basic properties of electric charges. In previous classes your previous knowledge is that you have studied in previous classes regarding some properties of the electric charge. Means like charges repel each other. Like charges repel each other and unlike charges attract each other. But there are some other properties which has been mentioned as the basic properties for the purpose of class 12, and these basic properties one by one we are going to discuss. First property is that one, additivity of electric charge. Next is quantization of charge, and third is conservation of charge. So step by step we will discuss these property of electric charge. Let's see. First of all, I am going to start with additivity of electric charge. Additivity of electric charge states that electric charges can be added algebraically. Means electric charges can be added algebraically. Why it is so? The reason is that one, we can add those physical quantity algebraically which are scalar. We have to add those quantity in the form of vectors which are vector quantities. Vectorically we can add those quantities, but here I am going to explain how we can add the electric charges. As electric charge is scalar quantity, that's why it has to be added algebraically. Let us see what is the meaning of algebraically. Suppose I have a system of 2 point charges. This is plus q1, this is plus q2. Okay. So what will be the total charge of the system? The total charge of the system you have to add them algebraically, q1 plus q2. So this is the total charge of the system. I have added that these two magnitude of these two charges algebraically. Now suppose if I have a system of n charges, q1, q2, q3 dot dot qn, then the total charge of the system can be written as q1 plus q2 plus q3 dot 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 plus up to qn. So like this way electric charges can be added algebraically, and this property of electric charge is known as additivity of electric charge. Now one important fact, electric charge is a scalar quantity. It is a scalar quantity. Why it is so? It is a scalar quantity because it has only magnitude but no direction. Means those physical quantities which have only magnitude but no direction are said scalar quantity, and electric charge falls in this category. Next, and SI unit of electric charge is coulomb. This is the SI unit of electric charge. And smaller units of electric charges are very important because in numerical we will use these smaller unit of electric charge. Here I write 1 mu c, mu that is the abbreviated form of microcoulomb, and it consists of 10 to the power minus 6 coulomb. You can write 1 microcoulomb is equal to 10 to the power minus 6 coulomb. Similarly 1 picocoulomb that is equal to 10 to the power minus 12 coulomb. I can write 1 picocoulomb is equal to 1 microcoulomb, and that is equal to 10 to the power minus 12 coulomb. So I have explained you additivity of electric charges. Once again is the time of a basic problem which is based on additivity of charge. Let us see how we can solve the problems which are based on additivity of electric charges. Suppose Question: suppose a system has four charges of magnitude plus 2q minus 5q plus 7q माइनस q. ठीक है. What is the total charge of the system? So here we have to apply once again the additivity of electric charges, and additivity of electric charge states that these electric charges can be added algebraically. Let us see how we can do that one. Answer: net charge or total charge on system, that will come out first charge plus 2q plus with sign minus 5q plus 7q plus with sign minus q. Now I can write 2q minus 5q plus 7q minus q. Minus 5q minus q plus 2q plus 7q. That comes out to be plus 7 and 2 9q minus 5 minus q. That comes out to be minus 6q. The answer is plus 3q. So like this way we can add electric charges algebraically. So I have here added the electric charges algebraically. This property is known as additivity of electric charges. Okay, now we come to the next property, and the next property is, please once again, now we come to the next property, and the next property is I have quantization of charge. Quantization of electric charge. Okay, suppose I have three bodies. Suppose this is A, this is B, and like this one, this is any object C. If I measure the charge on this body, suppose this is body number first, this is body number second, this is body number third. These all bodies are charged. If I measure the electric charge on these bodies, then it comes out to be like this one, plus 2e minus 4e plus 6e, like this one. So one important thing I have observed here, what important thing, that the charge on the body is everywhere E is multiplied. 2 minus 4, 6, these are integer. The quantization of body or quantization of electric charge states that electric charge, it states that electric charge on a body, on a charged body is always an integral multiple, INT, integral multiple of E, small e. What is small e? This is the basic unit of charge. This is basic unit of electric charge. So once again going to explain you. Suppose I have three bodies, first, second, third. When I measure the electric charge on these three bodies, it comes out to be that plus 2e minus 4e plus 6e. So I have observed that charge on a charge body is multiplied by a number. Multiplied by a number. E is the basic unit of charge. So I can say quantization of charge states that electric charge on a charge body is always an integral multiple of E, that is basic unit of electric charge. So I can write down electric charge on a body. This is the formula, Q is equal to NE. This is the mathematically you can express the quantization of charge, where N is an any integer. यहाँ पे N क्या है? This is any integer. And E, this is the basic unit of charge or the fundamental charge. Fundamental charge. And you know that fundamental charge, that is equal to the charge on an electron, and you have to write down its value is 1.6 into 10 to the power 19 coulomb. And we know that we have already discussed bodies are charged by the transference of electrons. So E, you can say here, it's the magnitude of electric charge on an electron. And what is N here? N, I write down any integer. You can write down, actually this is integer, by this means N is the number of free electrons also. So this states that electrons are always transferred when we rub two bodies each other. When the bodies get charged due to transference of the electron, and electrons are transferred in the form of integer, not in the form of fraction. Okay, so this is quantization of charge. What I told, electric charge on a charge body is always an integral multiple of basic unit of charge. Mathematically, I can express this Q is equal to NE. N is an integer, E is a fundamental charge or the basic unit of charge. Its value is 1.6 into 10 to the power minus 19 coulomb. And you can say what is an integer, that is actually the number of free electrons. And we know that bodies get charged by the transference of electron. So this is the quantization of electric charge. Now we come to the third property, that is the conservation of charge. Very simple. And this property states that conservation of electric charge. Conservation of electric charge. It says that during any process, the total charge of an isolated system remains conserved or constant. We can explain it in another way, and that is, or in other words, you can say electric charge can neither be created, electric charges can neither be created nor not destroyed. So what I explained now, I explained you conservation of electric charge. It clearly states that during any process, the total charge of an isolated system remains conserved or constant. In another word, I can say that electric charges can neither be created nor can be destroyed. We can explain it with the help of one activity that I have performed. I said when I rub, suppose this is glass rod, I rub with silk cloth. I rub with silk cloth. What I have observed? I observed that glass rod develop positive charge. Okay? But when I bring this positively charged glass rod near the silk cloth, what will happen? They will start attracting each other. It clearly depicts that the amount of positive charge which has been produced on glass rod, that is positive, the same amount of negative charge is developed on the silk cloth also. So I can say the total charge of an isolated system means this glass rod and silk cloth, the total charge is constant. Okay, so conservation of charge can be explained on the basis of this activity also. I have not created nor destroyed. Actually, that charge, the electrons are transferred from one body to another body, but total electric charge of the system means glass rod and the silk cloth remains constant. I hope that you understand these basic properties of electric charges well. If you have any problem, then kindly can send your comments in comment box also, and I will try to sort out your problems in my next video. Thank you. Have a nice day.